My name is Nana Okoye, and together with Richmond Kujo, we worked on a project titled Virtual Crude Oil Refinery Simulator. So, this project uses MATLAB to simulate how crude oil is separated into useful products like petrol and diesel using their various yield percentages. More importantly, it shows how the yield percentages of these products change with the changes in temperature. So, in actual fact, crude oil is made up of different components and it must be refined before use. This is done by heating the crude oil, and as the temperature increases, different components are separated based on their boiling point. In our simulation, we model this process by assigning yield percentages to each product. As the temperature changes, the amount of each product produced also changes rather than just appearing at the fixed point. So now, for example, at lower temperatures, the yield of lighter products like gas and petrol is higher. As temperature increases, the yield shifts toward heavier products like diesel. So at very high temperatures, more of the residue fuel are also produced. So now we implemented this system in MATLAB where the program calculates and updates the yield of each product based on temperature. We also included what's the name? It was basically what we did for the MATLAB presentation. So we also included a chart of how the various yield percentages correspond to the various useful products of the crude oil refining. So we implemented this thing in MATLAB
at um, a temperature between 125 degrees Celsius and 250 degrees Celsius, we see how that the percentage yield is 40 percent for petrol, and then it decreases to that of diesel and then the residue. So as we were saying earlier, the percentage yield depends on the temperature differences. So when the temperature is at a very low place, it yields more towards the lighter one, the lighter product in the crude oil, which is the petrol. And then we made use of the this component in the app, that's the slider, the gauge. The gauge shows the temperature, the pressure at which the system is working, and then the lamp shows us how that the app is working, or the simulation refinery system is working. So this is an indicator that shows us that the simulation app is working, and then the slider is used to change the various temperatures in the system. Yes, and then this is basically the codes that we run to make the app. So we had the various assumptions or the various conditions. So when the temperature is less than 40 degrees, the residue has a higher um, percentage, and then if the temperature is greater than 40 degrees, greater or equal to 40 degrees, we have petroleum, and then petroleum and the residue sharing this up. And then we also made sure that our graph consisted of the four components, that's the petroleum, the kerosene, the diesel, and then the residue. So this is basically how that we code. So these are the codes that were responsible for making the app. So when you run it from this side, you get ah you get the simulator. When you move the simulator, it gives you the percentage yield of the various crude components, that's the petrol, the kerosene, the diesel, and then the residue.
Alright, so conclusion, this project demonstrates that refinery is not just about separating products, but a lot goes into it in the sense that it is more about or the yield of each product. It provides a simple but effective digital representation of a real petrochemical refining system. Thank you very much.